Good morning. It's Friday, and I'm leaving you with a lab to do, and I wanted you just to kind of follow this video and be able to set it up and collect all your data. First of all, the goal of this lab is to actually calculate the charge of an electron. Now, that's where we've kind of been looking at things from a historical perspective, and the electron's a very important piece when we start to look at chemistry. And so we wanted to see if you could actually do something that other people have done in the past, which is find out what the charge of an electron is. We're going to be using a method called electroplating as a way to do it, and we're going to use some electrodes that contain the element zinc in them. So these are galvanized nails. Galvanized nails actually have some zinc coating on them. And our goal is to take some of the zinc off of one of the nails and put it on the other nail. So we're going to actually push that electron or push those atoms across the solution and find the mass difference that happens on that. So that's our goal for this. So before you begin, you will have to get your nails from the box at the front of the table. You'll want to make sure that you mark them so that you know which one is which. So like I'm going to mark this as nail 1 and nail 2. Okay, so we want to put some kind of a mark on them so that we know the difference between them. So nail 1 and nail 2. And then you'll want to find the mass of them. So I've got kind of the electric balance here, so we're going to turn that on. And we want to know the mass of the first nail and record that value. Um, I don't have a sheet for you today because all of your data is going to be entered into the link that I gave you. And then we get the mass of the second nail. Okay, and so we get those two masses, write those numbers down so you have those for later. And then we have to do a setup. Now, it's an electroplating thing, so we have to actually use some electricity to actually push atoms across. And in order to do that, we've got this box right here. This is our power supply. So this is takes place of like the battery. From there, we have connector or wires that are going across from these two terminals. This is the knob that's going to turn it on and off. Make sure that you keep it off right now. And we're going to try to do two setups from each power supply. So you're going to have two cords, sets of cords. So you can see one lab group is going to go this direction, the other lab group is going to go this direction. From there you go from your power supply to one of these two boxes. So this is an amp meter. This is an analog amp meter, and I'll bring it a little closer so you can kind of see. It has two sets of gauges on it, so it reads both in this one here, 0 to 3 amps and 0 to 30 amps, and we want to use the 0 to 3 amps, or at least the smaller of the two. And then we have our other terminal here that we connect to. And when you read the gauge, you'll read the gauge going across here, and that's what will do that. And so I'm just going to hook this back up. So again, power supply goes to our amp meter. Our amp meter then comes back to where we're going to have a nail. And then we go from the other end of the power supply to the other end of the nail. So that's our basic setup. And if you need to, you should pause it at this point so you can kind of make sure that you've got everything set up and ready to go. I'm just going to show the other meter is a multimeter, so it's a digital version. We want to make sure that it's turned on to the 10 amp reading. So again, it's a maximum of 10 amps, and that these two are plugged in. So the one is plugged into the 10 amp and the other one is your ground, and that's your two posts for your amp meter. So we'll let you go ahead and set that up, and then we'll come back. Alright, so now hopefully you've got your circuit all set up. Now we just need to get some solution in here, and the solution is actually back in the fume hood in the containers. So you'll need to take your beaker, your 250 milliliter beaker, and we're looking to get about somewhere between 150 to 200 milliliters of solution. Now once we have that solution, I gotta grab my goggles. once we have this solution, this is the electrolyte that's going to allow our electrons to go flowing between. It is a zinc solution, so it's a zinc sulfate solution. And we want to make sure that we put our nails in there so that they get into the solution. Now the key here is you do not want your two nails to touch. If the nails end up touching each other, then you're creating a short circuit and you're actually not going to do well in the lab. So you want to make sure that, because you have 2 to 3 people, make sure somebody's kind of holding the nails in place so that you don't end up losing anything. Okay, and I'm just going to make sure I've got them in the spot so they're not going to touch. Okay, and now what we'll do is we're going to go ahead and turn our power on. Now, when we turn the power on, we're going to want to watch our amp meter, and we're looking to make sure that it gives us a positive reading. So you got to watch that needle to make sure that the needle goes up. If the needle goes backwards, or if it shows a negative value, we just switch these two wires around, and then we'll be okay. So I'm going to go ahead and turn on my power here, and I'm looking to make sure. Oh, got to make sure that the power supply is plugged in. Okay, so we're going to be looking, and I see it went to the negative side, so I do have to switch these around. Now I can get my reading. And we want to make sure that we're pushing enough voltage so that we get about less than 1 amp, okay, but we want to be more than half of an amp. So anywhere between half to 1 amp is what we're looking for. And you're going to want to time the whole time that the current is on. So in other words, we need to make sure that we started a timer at this point, and we want to run it about 20 minutes. So you're looking to get about 20 minutes worth of electricity running through this. Every minute we want to take a reading from our amp meter to make sure we know where our current is at. We'd like that current to stay constant, so we want it to stay the same. So again, I'm going to keep track of what my current reading is every minute, because I want to be able to know what my average current was for the entire experiment. So I'm watching this, and it's giving me my reading, and again, I should be able to read this to the proper number of significant figures. And while that one's working, you can kind of see what's going on here. Let's see if I can bring this in closer. But you got, one of your nails is going to be growing some stuff on it, so you need to make sure that you're careful with that nail, because that's the one that's gaining mass. The other one is actually losing its mass because the zinc is going into the solution, so the zinc is then coming back out of solution. All right. At this point, you're just watching and maintaining it, and remember, watch your current flow and take an average, or take a reading every minute so that we can get a good average. All right, and we will be back in about 20 minutes. All right, now we're back, and I've got my solutions after the 20 minutes of time, and what we need to do is take these out, and we want to be very, very careful not to lose any of the zinc off of the nails. And we're going to actually go through and kind of do a process of cleaning and drying the nails. So it goes like this. You're going to take your nails. The first beaker is going to be just distilled water. And you just gently dip them into the distilled water. And then you go gently into the ethyl alcohol. And then you rest these on a piece of paper towel so that they can dry. And after they're dried, you're going to find the mass, and that'll be your mass after for each of the nails. And that'll be it with the nails. After you have your mass, the nails go into the beaker up here. And your solution will go into the large beaker right there. You can take the beaker, rinse it back out with water, and then leave it on your lab station. And then I'll come back to talk to you a little bit about the calculation.